Good morning, students. It's Devo Miss who is going to take your physics class. As we have studied yesterday about repetitive motion, this repetitive motion is of two types, that is periodic and non-periodic motion. Periodic motion are those which takes place at fixed interval of time. This motion always takes place at a regular interval of time, like the rotation of Earth on its own axis. It happens every day and its occurrence takes place at regular fixed interval of time. The motion of Moon around the Earth is also a regular event which takes place at a fixed interval of time. Now, motion of all the planets around the Earth is also a periodic motion because all these events occur at a fixed interval of time. There is another repetitive motion which does not repeat itself after a fixed interval of time, and such motion are known as non-periodic motion. Today I am going to explain you a device known as simple pendulum. Simple pendulum shows the best examples of periodic motion. What is a simple pendulum? A simple pendulum consists of a heavy point suspended from a rigid support by a weightless, inextensible string. This string has no weight at all, and it consists of a round metallic object at its end, which is known as bob. When this pendulum is at rest, this bob is said to be at its mean position. This pendulum shows a motion like it moves to left and then to right, and this type of motion is known as to and fro motion. This to and fro motion is known as oscillatory motion. When we push the bob moves to A and then it moves to B. This movement of bob to its both corners is known as extreme position. So here A and B are the extreme position. When the pendulum is at rest, this O is the mean position, and when it is in movement, A and B are the extreme position. I hope you all have understood till now. Now next is the terms related to simple pendulum. First is oscillation. When we push the bob first moves to A, that is, it moves from O to A, then it moves from A to B, and again it moves from B to O. So the movement of the bob from O to A, then A to B, and again back from B to O is known as one complete oscillation. So, oscillation is the to and fro movement of the bob from left to right and from right to the center. I hope you all have understood it. And when it comes at center, then it is said that it has completed one oscillation. Now the maximum displacement of bob, which I was telling you just now, that is the movement of bob at the extreme end from the mean position. When the bob moves from O to A and when it moves from O to B, this maximum movement of the bob is known as amplitude. So OA and OB of the pendulum is the amplitude. And the time taken by the bob to complete one oscillation, that is its movement from O to A, from A to B and back from B to O, is calculated as one oscillation. When it completes one oscillation, it is known as one time period, and this time period is calculated in terms of second. Now, number of oscillation completed by the bob in 1 second is called its frequency. The SI unit of frequency is Hertz, which is denoted by capital H and small z. So time period and the frequency are related like this. Frequency is the reciprocal of time period, or time period is reciprocal of frequency. Length of the pendulum. The length of the pendulum is the distance from the point of suspension of the pendulum to the center of the bob, and its SI unit is meter. Like this is the length of the pendulum. Understood? So this is the terms related to simple pendulum, and this is the term related to simple pendulum, and a simple pendulum gives you the best example of to and fro motion, and this to and fro motion is known as oscillation. There is seconds pendulum. A second pendulum is one whose time period is 2 seconds. And the length of the inextensible string is only 1 meter. So for today, till this much, I hope you all have understood it. Yes, I hope you all have understood it. And your assignment for today is to draw a simple pendulum. You have to draw a very neat label diagram of a simple pendulum, that is from page 24, figure 2.13. At the same time, you have to write the difference between periodic and non-periodic motion. Till then, stay safe, stay healthy. Bye.